everyone, I'm Hermione Granger. Yes, from Harry Potter. Miss Ludkey asked if I would be willing to help out with her lesson today, and I said of course. So here's what we're going to learn about. First things first, I'd like to ask you a very important question. When you're playing dodgeball, it's fun, right? Yes, but what would you say if somebody asked you to play dodgeball with a bowling ball instead? You know instinctually that would not feel good. Ooh, that's just a clever idea to get us all killed, or worse, expelled. Today we're going to learn the science of why it would hurt to play dodgeball with a bowling ball. Let's try it. To answer that question, you might say that a bowling ball weighs more, and you would be correct. But what if I said a bowling ball isn't that much bigger than a dodgeball? They're roughly the same size. So they have to weigh about the same amount. What would you say to that? You would be correct to tell me that I was wrong. And I'm not usually wrong because I'm Hermione Granger and I'm always right. A bowling ball and a dodgeball are about the same size, but they have different weights. Another way that we can say that is that a dodgeball has less mass. Since a bowling ball and a dodgeball are about the same size, if we put them into a container, they would take up the same amount of space in that container. Another way to say this is that they have the same volume. Now this is where the word of the day comes in. Are you ready? Excellent. The word of the day is density. Now on your exit ticket, you're going to have to put the word of the day. This is to see if you're really watching the video. So here's how you spell it. Get ready. Are you ready to write it down so you can put it in your exit ticket? Good. Remember, the word is density. You spell that D-E-N-S-I-T-Y. Let's spell it one more time just to make sure that you've got it correct. Ready? D-E-N-S-I-T-Y. Density. Density is how much space something takes up in relation to how much it weighs. Which ball do you think is more dense? A bowling ball or a dodgeball? Which ball would float if you threw it into a swimming pool? Here's a hint. Both answers should be the same. To explore density, we're going to do a really quick experiment called Can You Make a Rainbow in a Jar? Let's see that experiment. Welcome to potions. No, oh, not potions, science. Sorry, I've been at Hogwarts for too long. So today we're going to do an experiment. And the experiment today is, can you make a rainbow in a jar? I would love to do an experiment to find out what do we need? It's a really good question. The first thing that you need is some warm water. 4 little containers. I'm just using little glasses to put some of the water in. Food colouring. I've got red for Gryffindor, green for Slytherin, yellow for Hufflepuff, and blue for Ravenclaw. Some sugar, a measuring spoon. I've got one with a black cat on it. A straw. I'm using a reusable one. The last thing that you need is a little glass jar so that you can see through it. You could also just use a glass cup, but it has to be so you can see the rainbow. The first step in the experiment is to put water into each of the glasses. Remember, you should be using warm water. Next, we're going to put in the food colouring. Gryffindor, Hufflepuff, Ravenclaw, and Slytherin. The next step is to add in the sugar. The red glass gets 1 spoonful of sugar. The yellow glass gets 2 spoonfuls of sugar. The green glass gets 3 spoonfuls of sugar. And the blue glass gets 4. Now I'm going to use my straw to stir it all in. You want to stir until the sugar is completely dissolved. If the sugar isn't dissolving, you might want to put it in the microwave to heat up the water. When all of the sugar is dissolved, we're ready to move on to the next step. I'm going to start out with the blue water. I'm going to put a little bit inside this glass jar. Careful now. If you make a mess, you'll have to clean it up. That's enough. Now I'm going to take my straw and the green water, and I'm going to make a pipette out of the straw. All I'm going to do is put the straw into the water and then cover the top with my finger. Do you see how some of the coloured water is held into the straw? Now I'm going to very carefully put this into here. I'm going to put it off to the side and gently let go. And I'm just going to keep doing this until I've got about the same amount of green water. Excellent. Then I'm going to move on to the yellow water. And the last colour that I put in was red. See all the different colours inside of this jar. There is a rainbow in this jar. We did it. So I've got my rainbow jar right here. It was a lot easier to see when I had the camera the other way, but we can still see that there's different colours throughout. Remember, we only put 1 spoonful of sugar in the red, whereas we put 4 spoonfuls of sugar in the blue. Now we know that when we put sugar into water, the sugar doesn't disappear, right? No, I can show you that by weighing it. Are you ready? Let's see. All right, we're going to test this by weighing out some of our own materials. I've got this bowl right here because I've got 2 of the same bowls, so I know that I'll be able to use the measurements from them. I have it weighed at 21 grams. Now I know how much the bowl weighs. This is the same bowl with some water in it. It says it's 101 grams. I know that the bowl weighs 21 grams. What's 101 minus 21? You're right, 80 grams. So the water weighs 80 grams. It's at 40 grams. But what's 40 minus 21? 19. So this is really 19 grams of sugar. Remember, the water was 80 grams. But when we measure it all together, it's at 101. So when I put in the sugar, which was 19 grams, my prediction is that this right here is going to say 120 because the sugar doesn't disappear even when it dissolves. Let's test it. Would you look at that? It might say 121, but that might be because of the measurements. Now we know for sure that when we put the sugar in the water, it didn't go anywhere. The water weighed a little bit more when we put the sugar into it. So let's think. We put the least amount of sugar in the red water. So that means that the red water weighed the most or the least. The red water weighed the least. It had the lowest weight because we put in less sugar. Even when I stirred to dissolve it, the sugar was still there. So the blue water was going to be the heaviest. So why do you think the blue water stayed on the bottom while the red water stayed on the top? And because I know that you are all wonderful scientists, I'm going to let you answer the question in your exit ticket this week. So the question is, which color of water was more dense? Which color of water was more dense? Was the blue water, the green water, the yellow water, or the red water more dense? You're going to tell me which one in a full sentence. Because if you just say one color, I'm going to be like, are you talking about Skittles? Are you talking about Fruit Loops? Are you talking about a flower that you saw? You need to use full sentences. This color of water was the most dense. I know that you can do it. I'm so excited to read all of your answers. I wonder who I'm going to be next week. Bye guys. Happy learning.